This is the tutorial of a gear mechanism. So we're gonna have a pinion, gear, rack in this assembly, and then we're gonna rotate a pinion with a certain RPM, and we're gonna see how this gear will reduce with the ratio based on the differences of a radius. And also we're gonna assign the different ratio based on the gear and rack as well too. In addition to that, we're gonna have one more gear going on the different angle, showing that in CATiA we don't have to have aligned the gear for the gear mechanism, even though they are totally different axes, or even though they are not parallel each other, it will be able to simulate it. So I'm gonna start with assembly. So this is our base. I plan to put pinion here, gear here, and rack here, and I'm gonna put another gear here. One gear here, one more, so I have 2 gears now. And there's a rack. Okay. So in assembly, I'm gonna fix the base first. I'm gonna maneuver in extraction the parts a little bit away so that you can easily align. So I'm gonna use a coincident axis of a pinion, axis of a base, and rotate a little more. Face of a pinion, face of a base. So rotated pinion will be in position. Same. Axis. And I'll rotate it. Oh, destruction is not right, so I'll fix that. Okay, now it's fixed. So now you can see the pinions, gear in positions. Okay, and it's sharing the same axis with the base hole we already have. As you can see, I added one more gear, exactly the same part in the different positions. As you can see, about 90-degree off from those 2 gears you already have. So later on, we're gonna simulate those 2 gears later on also too. And then I also updated a position for the rack. Again, as you can see, this face and this face coincident, and also the line and line being coincident. So that's how it's been made now. So with that, then we can move on to kinematic simulation. All right, so moving on to the kinematics. All right, so what we're gonna need for the gear joint is requirements of 2 revolute joint. Okay, if you jump into the gear joint, what is asking is, again, give me the revolute joint 1, give me the revolute joint 2, and you're gonna set up the ratio. There's automatic definitions. You can by clicking the diameter, you will update it, or you can manually change it as well too. So let's start to build the gear joint. So to do that, again, requirements of revolute joint, you can build up once you start gear joint. I don't have it yet, so I'm gonna create a new one and so on and so on. Or you can just create it in the early stages so that you can just pick up those revolute joints. So let me start with fixing the part, new mechanism. So base will be fixed, then revolute joint. Okay, just like we did it before, we're gonna start with the line as an axis of pinion gear, hide it, then axis of the hole I have in the base. And for the plane, I can go to hidden place, I can pick up this plane, then I can pick up this plane. So they're the normal each other. There we go. So I can bring it back. The same thing, repeating all these two. To save time, let me move quickly. Alright, I just finished adding the two more revolute joint just as a pinion. Axis, axis, plane, plane, same thing. Axis of a gear, axis of a hole, plane, plane, same thing I did it too. So we have a three revolute joint. Here's the first one, here's the second one, and here's the third one. So now I'm gonna have another joint here, which is prismatic joint, so that you can make a linear movement. So prismatic joint. In this case, okay, what we are looking for is a line. So line, then parallel to those lines. So this plane, or this plane and this plane should work as a two. So let me say, how about this plane and this plane? There we go. So I got the prismatic joint. So now the tricky part is once you create a gear joint, consuming those two revolute joint, okay, so it's revolute 1 and revolute 2, then the ratio, again, the size difference should be the ratio. If you know already know, then you can put it, or you can just say define radius 1 is this circle, radius 2 is this circle. Then, as you can see, it automatically updated for you. Then say, and when you say okay and see what happened, the revolute 1 revolute joint you had will be gone, and it will be consumed by gear joint if you just use those two. So when you try to make another joint between this gear and this gear, there's no revolute joint I can actually use it. So if it happens, then again, don't be afraid to create another one. I know we already have exactly the same thing, but you can create it the same thing again so that you can use for another joint for later on. So I'm going to create one more revolute joint quickly, then I'm going to show you how to add the rect joint between. Okay, I made two more revolute joint, one for creating the rect joint here, and I'm gonna use another revolute joint for this one with this revolute joint so that I can create another gear joint there. So the plan is one gear joint between pinion and gear, which is we already did, and now I'm gonna create rect and another gear. Right. So gear joint between let me start with the rect joint first. Rect joint require the prismatic joint and a revolute joint. So I already made a prismatic joint for this. So this one. And the revolute joint, which I already have as a revolute 3. So I'm going to use that. So as you can see, the ratio based on the circumference of the gear actually it automatically generate the ratio between the gear and the rect. Okay, then you can see it. The prismatic joint and regular joint that we had will be consumed by reg joints. So now I have a regular joint here, which is regular 4. I have a regular joint here, which is regular 5, making another gear joint. Gear joint between this and this. Again, in this case, both are same diameter, so this case is 1. But if you want, if the case is required, you can actually modify the speed as you wanted it. So as an example, let's say as you make this one as a 1 rotation, let's say you want to make this one as half. So then you can make it half, something like that. So again, many cases the gears and gears are opposite directions, but again, you can simulate a case of a belt or chain. So in this case, even though there are different axes, you can make it as a same or opposite, again, depending on you need it. So now we can see gear joint between pinion and gear, and rack joint here, and independently there is another gear joint between those two. So we're gonna take this degree of freedom we have. We're gonna make a relationship, and let's see how it goes. All right, so right now we have one gear joint. Again, repeating, rack joint, and we made another gear joint between these two. So as you can see, now it's 1 degree of freedom. The reason is we have one free to rotate it. This one cause rotation of this. This one this rotation should cause linear movement of this rack. Also, this rotation should cause rotation of this one. That's why only 1 degree of freedom. So we can take that as our command. So let's double click. Then you can see which one is gonna be the driving mechanism. So in this case, it's obviously the first one, the angle 1. That's our driving mechanism. You can see also you can change the directions. So we're gonna make it as a clockwise. Then there's something wrong. So gear is opposite. Change it. And again, the range will be 0 degree to, let's say, 2 times. So that means, or 3 times, there will be 1080 degree. So 3 rotations. Then as soon as you say OK, then right away you can see that, right, because that single degree of freedom we had was taken to command is able to be simulated. So if we test it now, so simulate mechanism 1, OK. So from 0 to 360 degree as 1 rotation, then you can see all other joint is moving together. So let me try again. I think I turned on the wrong one. So this one. So from 0 degree to, let's say, 10 rotation. So 3600 degree. Okay. So now if I simulate again based on that mechanism, as making the 10 rotation, as you can see, one gear and the other gear and also rack is moving. So if you insert this in and divide it, if you make it as a back and forth, you can see how it's moving each other. So opposite directions, rotation and linear direction match. the opposite directions, and so on. That's good. Then we are going to add a law, which is defining your speed or acceleration. So in this case, if you choose your mechanism, then we have your angle and kinematics time. So in this case, let's say that we're gonna rotate as 100 RPM, then 100 multiply 360 degree per 1 minute, then make it as a 100 RPM. Since 360 degree divided by 1 minute will be 1 RPM multiplied by 100, then 100 RPM, and multiply time kinematics time, so that the units are homogeneous from the angle and to angle. So time term will be gone. So it's matched. So okay. Then you can add a sensor and wherever you want. So in this case, let's say you want to see your pinions rotation. So in that case, you can actually use the origin of your pinion base sketch as your sensor location. So reference will be your base, point of selection will be your origin of the sketch used to create a base. Okay. Then one more, same thing. Let's say I want to check the speed of my rack. So base will be the reference point. You can pick up anywhere the vertex point. You can add the sensor. And since we have a law and sensors added, we can simulate with the law. Then this is 10 kinematic times, so you can actually modify it depending on how long you want to rotate it. So as an example, right now we have 100 RPM as a law. So if you want to see, depending on how many rotation you want to see, you can adjust the time. So we are expecting within 60 seconds 100 rotation. So let's say just 10 seconds is fine. Or maybe reduce to 5 seconds. Let's see within 5 seconds what's happening. Say OK. Then we're going to divide this whole step into multiple steps. Activate a sensor. Then you can say I want to see the rotation of opinion in based on x-axis. So you can go down and find out first sensor and x angular speed. Then I want to see in linear speed of my rack, which is in y direction. So if you're going down, there's a second sensor, then it's going to be at y linear speed. Okay, let me check. So instantaneous value, you can check the x angular speed of a sensor 1 and the y linear speed of a sensor 2, which is attached to rack. Then if you run the simulations, then you can track the value of your speed, and as you can see, exactly showing you what is the rotational speed, so 100 RPM. Then also it's showing you what kind of the speed of your rack is moving. So if you draw the graphics, 2 linear curves should show up. Green shows that your rack speed, which is meter per second now, and minus means just simply direction, positive, and negative, and yellow showing you that your RPM. So you can see it turn per minute, which is exactly RPM means. Well, that's how you're checking your simulation and add the sensor to check the rotation of gear and whether your whole gear trains works properly. That concluded this tutorial.